L-serine plays a key role in several anabolic processes, and is the precursor of D-serine and glycine, two coagonists of N-methyl D-aspartate receptors involved in several physiological functions in the human brain, and whose dysfunctions are responsible of neuropsychiatric and neurodegenerative diseases. L-serine in the brain is synthesized starting from the glycolytic intermediate 3-phosphoglycerate through the phosphorylated pathway, composed by 3 consecutive reactions catalyzed by D3-phosphoglycerate dehydrogenase, PHGDH, phosphosyrine aminotransferase, PSAT, and phosphosyrine phosphatase, PSP. D3-phosphoglycerate dehydrogenase has been characterized from a biochemical point of view. It is a cytosolic enzyme, which is responsible of the first step of the pathway. Human PHGDH, a complicated and promiscuous enzyme, is finely regulated. Its 3D structure has not been solved yet. The in silico model of the homotetramer shows for subunits that adopt different conformations, syn and anti, resulting in an internal asymmetry and different exposition to the solvent. Moreover, several PHGDH mutations have been correlated to pathological states. These variants have been produced in a recombinant form as well as overexpressed in a glioblastoma cell line to shed light on their biochemical properties. Human PSAT efficiently catalyzes the reversible transamination of 3-phosphohydroxypyruvate and L-glutamate to O-phosphoylserine and alpha-ketoglutarate. The catalytic parameters were determined in both directions, demonstrating that the forward reaction is the most efficient. We also solved the 3D structure of both the substrate-free and O-phosphorylserine-bound forms. In the crystal structure, we observed a sulfate ion bound in the active site. Binding of sulfate induces a closed conformation comparable to that stabilized by the substrate O-phosphorylserine. By fast-soaking PSAT crystals with the substrate O-phosphorylserine, we detected different catalytic intermediates in the active sites of the 8 protomers of the PSAT structure, shown here in different colors. PSAT variants reported to be associated with its deficiency and Newlax-Over syndrome were recombinantly produced and characterized. The association of PSAT variants with pathologies appears to stem from different mechanisms, including low PLP affinity and consequent thermal instability, aggregation, increased Km and decreased Kcat values. HPSP catalyzes the last irreversible step of the pathway. We developed a new activity assay and measured the catalytic parameters. The enzyme is very efficient, and is inhibited by both phosphate and L-serine products. Magnesium activates the enzyme and increases its thermal stability. Also, PSP variants are associated with serine deficiency disorders. The recombinant M52T and A35T variants, in agreement with observed pathological phenotype, show a 20-fold reduction of turnover number and a 3 to 4-fold increase in the IC50 for L-serine, without affecting the overall stability. Cellular studies performed on differentiated human astrocytes demonstrated that the 3 enzymes are in close proximity in the cytosol. Kinetic studies of the reconstituted pathway support cluster formation and indicate that PHGDH catalyzes the rate-limiting step, while PSP reaction is the driving force for the whole pathway. The phosphorylated pathway works as a cytosolic, multi-enzymatic metabolic assembly for L-serine synthesis, which fine regulation is still unknown.